How's it going, guys? In the previous video, we talked about levels of representation and how model-based computer vision is a top-down level which goes from functions to objects, to volumes, to surface, to edges, to dots. Now I'd like to continue and talk about the representation framework for deriving shape information on images. So this is a chart that was given to us, and in this chart we look at some of the approaches to understanding objects that's in the image. So we have a primal sketch, a 2.5D sketch, and a 3D sketch. And in a primal sketch, it is essentially recognizing the edges that's in an image. So it's a very rough trying to understand what's going on. So for example, if you were to scan image very quickly, what are the edges that you see in this picture? A 2.5D sketch is essentially the way that Dr. Lee described it is a viewer-centered coordinate frame. So suppose you have a three-dimensional object that's represented by this hand, and you are the viewer. Then to get a better sense of what's going on with this object, you would move yourself around to see what this object is, to get a different view of this three-dimensional object. And that's what we call viewer-centered coordinates, because the coordinates are centered around the viewer. The viewer is moving. We also have a different coordinate. It's called object-centered coordinate. An object-centered coordinate is when we center the coordinates around the object. So instead of the viewer moving, the object is turning around. But that essentially is the same thing as the viewers moving around. But instead, you have the object turning around. The coordinates is telling you about this object. So you have two different coordinate systems to understand a three-dimensional object. So here the object-centered coordinate frames tells us is a 3D model representation of what an image is, of what an object is. So Dr. Lee then went into details about segmentation and feature extraction. So we have an image, and we can segment an image into different parts. The example we have is, suppose you have an image that is the lecture frame, where you have black frames on the sides and white frames in the middle because it's the projector. Then you have a very distinguished line, this edge that separates the black and the white. But you wouldn't just have this one edge that's separated, because in reality, lines don't really exist. Right? Lines are always two-dimensional. So even if the line is 1 pixel in width, it still has some kind of surface area. And in this case, we have two edges, one that separates the black and the white. So on the left side is black, the right side is white, and the other edge on the other is one side is white and the other side is black. So we have two edges that separates the black and the white. So this is what we mean by segmentation. And we have different ways of recognizing objects. So segmentation feature extraction is one of them. Those two are the two of them. We also have other ways to distinguish um, three-dimensional to recognize three-dimensional objects from two-dimensional spaces. So one of them is shape from shadowing. So if you see some shadows on an object, then you would assume that, oh, because I have a shadow, it must be a 3D object, right? So if you see a circle, but it's got some shadow on it, then you would assume that it's very likely that it's a sphere. We also have stereo visions. So you have two cameras that sees things from two different angles. Then you know that it's possible that it's going to be a three-dimensional object. That's why the assumption is that most animals comes with two eyes, so that one eye would see from one direction, while the other eye sees from the other direction. And you put it together, you have a stereo vision, so you have some sort of perception of depth. And the other thing you will notice that if you move your head from left to the right, when you're focusing on some object, you're likely to have a better perception of the depth of that object, because now you have the image that's coming from this side and you have the image that's coming from this side. So that would give you a very good model of what a three-dimensional object would look like. And that's pretty much it before I go into histogram transformation.